Okay, welcome to this video where we're having a look through a practice paper for the Paper 1 Non-Calculator Foundation Tier exam. Now don't forget, once you have got this paper, you can get back to the video at any point by scanning the QR code on the front of the paper, but we are going to fire straight into this as we have no time to waste and start talking through these questions. So question 1 here says that there are 4 cards, there's a number on each card, write down the largest 4-digit number that can be made using the cards each only once. Now we want to put the largest number first, unless it specifies that the number has to be odd or even. We don't necessarily have to worry too much about putting certain numbers in certain positions. We just need to get the biggest number first, the next largest number second, and so on. So 9, 8, 7, 4. I've used the numbers once, and that is the largest number that can be made. On to question 2, it's asking us to write 0.19 as a fraction. So not forgetting to figure out or to look at what the final place value column is for this. The 9 is the last one, that's in the hundreds column. So if this is in the hundreds, that would be 19 over 100. And if there was another number after the 9, for example a 5, that would finish in the thousands column, and that would be 195 over 1000. So there we go, that is writing a decimal as a fraction. This next one's a great one. It says AB is a straight line, marked with a cross the midpoint of AB. Now, ideally, we would want to get a ruler out at this point and measure the line. Now let's imagine that we measure this line, and obviously you'd be able to do that on paper. But if we imagine we measure this line, so we've got our ruler out, so it goes from 0, and let's just imagine, and obviously I'm not going to draw a perfect ruler here, but 1, 2, 3, 4, let's just imagine it goes to 6. So if the line goes to 6, then you would measure it out. We'd look for the halfway point. Half of 6 is 3, so we would look up from 3 and we'd mark it out just in the middle there. Now I've not got a ruler on the screen, but you can sort of imagine how we would go about doing that question. So marking that midpoint out, we do want to measure the line and just measure it perfectly in the middle. And there we go, there is question 3. For question 4, it says to write down a multiple of 6 that is between 40 and 56. So a multiple of 6 is the 6 times table. I don't need to write out the whole 6 times table because I do know a number that I know is in the 6 times table. It goes to 36 after a few of those numbers. After that would be 42. After that would be 48 and so on. So there are 2 numbers that we can choose. We can choose 42 or 48. It doesn't matter which one. I'm just going to write 42, but you could write either. The only thing we wouldn't do, we wouldn't write down both of those numbers. As it says, write down a multiple. So just read the language carefully. If it said write down the multiples, then we would write down both. But this says write down a multiple. So we go 42 or 48 would both be fine. The next one is looking at the order of operations. So we need to know that multiplication comes before addition. So in this case, you could put brackets around the 7 times 10, or I tend to draw like a little bucket underneath to remember which bit to do first. So I need to do 2 plus, and then 7 times 10 is 70. 2 plus 70 is 72. So there we go, my final answer, 72. Not to be confused with just doing it from left to right, which would be 2 plus 7, and then timesing it by 10. That would not be following our order of operations. Now our next question says, here is the gauge for a fuel tank of the car. The fuel tank holds 52 litres of fuel. When the tank is full, the tank is 1/4 full of fuel. Work out how many more litres of fuel are needed to fill the tank. So it holds 52 litres when it's full. So we could start by working out a fraction of an amount to see how much is left. If something is split into 4 parts, which is what 1/4 is, then we need to divide by 4. So 52 divided by 4, I'm going to do this using bus stop to division, just to make sure I get it right. 4 goes into 5 once, remainder 1, it goes into 12 3 times. So each quarter, it's quite nice that we have a diagram for this, but each quarter is 13 litres. It does say how many more litres of fuel are needed to fill the tank. So we have these 3 sections, or this 3/4 that's left up here. We could have just thought, right, well, let's just work out what 3/4 is. If 1/4 is full, we have 3/4 left. But 3/4 will be equal to 3 times 13. Take your time to work that out, but that is 39 litres. So there we go, 1/4 is full, that's 13 litres. We need 39 more to get to that 52 to fill the tank. On to the next one. Jonathan has 8 cards. There's a number on each card. Work out the range of the numbers on the cards. Well, the range is the distance from the smallest to the biggest, or biggest to smallest, however you look at it. But these cards are not in size order. Now, it's going to help to put it in size order because I've just seen that we have to do median for part B. So let's put these in size order and we'll be able to see the smallest and biggest a bit clearer. If we didn't have to do the median, we could probably identify the smallest and biggest without, but we're going to need to anyway. So we have 1. I'm going to cross them off as I go. 2 and 2. And we have 2 3s. We have a 6, a 7, and an 8, and I can really clearly see now the largest is 8, the smallest is 1, so for the range I'm going to do 8 take away 1, which is equal to 7, so my range would be 7. And then part B is asking us to do the median. So to find the median, I'm just going to cross a number off either side till I get there, so cross 1 off, and then another, and then another, and for this one we actually get 2 numbers in the middle. If those 2 numbers are different, we would need to find out what's in the middle of those. For example, if it was 3 and 4, well, in between 3 and 4 is 3.5. So I may need to add the 2 numbers together and halve my answer. But if both the numbers are the same, then that is the median. That's the number in the middle, even though there's 2. They are both the same, so my median is 3. And there we go, that's my median. The next question here is saying the probability of an event is shown by the cross on the probability scale. Write down an estimate for the probability of the event. Now, when we are doing an estimate here, we are just doing it as sort of logically as we can. We don't need to get a ruler out for this one and measure to see if that's perfectly in the middle. It does look like it's in the middle, so it'd be fair for us to estimate that that's in the middle there, in the middle of 0 and 1. Not forgetting 0 is impossible and 1 is absolutely certain. In the middle is 1/2. You could write that as a percentage or as a decimal as well. And then you have other fractions along the way here. So we normally have 1/4 and 3/4 sort of labelled, 1/4 representing sort of unlikely, 3/4 representing likely. But we have this half in the middle. That is the estimate for this probability. So we would say 1/2, or you could say 50%. So there we go. There would be my estimate for that one there in the middle of the line. Question 9, Savannah is 1.88 metres tall. Charlie is 6 centimetres taller than Savannah. How tall is Charlie? Well, both of these are in different units, so we're going to want to convert that amount of metres into centimetres. There are 100 centimetres in 1 metre. So 1.88, you can write it as times by 100 if you like, but hopefully you would know there's 100 centimetres in the 1, and then you've got 88 centimetres left over. So that's 188 centimetres. So Charlie is 6 centimetres taller. So we want to add 6 centimetres to that, just to see what we get there. So 8 plus 6 gives us 14. 8 plus 1 is 9. And then the 1, so that's 194 centimetres. So Charlie is 194 centimetres. Now the dotted line there doesn't say it has to be in centimetres, so you could either write that as 194 centimetres, or we could convert it back into metres, and we could write 1.94 metres. Either answer would be fine there. If we had centimetres on the dotted line, or if the question said give your answer in centimetres, of course we'd have to give it in centimetres. Now this one doesn't, so you can give that either in centimetres or in metres. But there we go, converting into the same units and adding it on. Question 10, we have some coordinates. So this one says write down the coordinates of point B. So with a coordinate, just make sure you don't get the x and y mixed up. We need to first go along the x-axis, and you can see it lines up with the 4, and then going up to its position on the y-axis, it lines up with the 5. So hopefully you remember, perhaps from a long time ago now, but you've got the along the corridor, up the stairs, so along the corridor, along the x-axis to 4, and then up to 5, up the y-axis. So 4 and 5 is our coordinate. Now the next one says find the coordinates of the midpoint of AB. Now the midpoint is the point directly in the middle of the two. So if we're looking at A and B, you could do this with a ruler, or you can try and spot a pattern, or you can do it mathematically with the actual coordinates. Now it does tend to be that sometimes these can come out as not the nicest of numbers. They can come out as decimals. So if you can't see it perfectly straight away, then you may need to sort of think about those numbers. But if we join these up with a ruler, let's just join them up. There you go. You can actually see there is a coordinate perfectly in the middle, and it sort of follows a pattern here. If you go along by 3, up by 1, that gets you to this point here. Along by 3, up by 1 gets you to that final point. So as it follows the same pattern, that is directly in the middle. That coordinate there, which I've drawn in green, is the coordinate 1 along the x-axis and 4 on the y-axis. So that is the coordinate 1, 4. If you're not sure, or it looks like it's perhaps between a coordinate, you can add the two x coordinates together and halve your answer, and you can add the y coordinates together and halve your answer. So looking at the y coordinate of A, which is 3, and the y coordinate of B, which is 5, if you add them together we get 8, and divide it by 2, you get 4, which matches our y coordinate. You can do that with both of them. Part C says, on the grid, draw the line with equation y is equal to -3. Now these equations here, they're not trying to trick you. Y equals -3. Well, look at the graph. Where is the point y equals -3? Well, it's on the y-axis and it's down here at -3. So all you have to do is draw a line through it. That's all it's asking you to do. Draw a line with equation where y is equal to -3. Now, it's not going to be up and down through that point because we know that that is called the y-axis. There's only one other way you can do, and it's drawing a nice straight line through y is equal to -3. If you want, you can label it, you don't have to, but y is equal to -3 is that line there. It's a straight line going through y equals -3. And there we go, there is drawing our straight line. You could also have to draw a vertical line if it said draw it through, let's say x is equal to -3. You would instead find x here on -3 and draw a vertical line going through that. Okay, on to question 11. Write the following fractions in order of size and start with the smallest fraction. Well, when we are ordering fractions, there's quite a lot here. There's 5 fractions. We want those denominators to be the same. So typically, have a look for the biggest denominator in terms of the size of the number. We have 12 over here. So can we turn them all into 12? Well, we could definitely turn the 4s into 12. We can do the 3 and we can do the 2. So yes, we can make these all out of 12. So 1/3, we'd have to times the top and bottom by 4. So that would give us 4 over 12. 3/4, we would have to times the top and bottom by 3 to make the denominator 12. That would give us 9 over 12. Same for the 1/4, so that would give us 3 over 12. And for the half, we've got to times the top and bottom by 6. That's 6 over 12. Now they're all over 12, we just need to look at the numerators. We're going to put the original fractions back in order. As it says, write the following fractions in order of size, not your new ones. So starting with the smallest fraction, we have the 3 out of 12, which is 1/4. And as you go, you can tick them off so you don't have to keep looking at all of them. You then have the 1/3, which is the 4 over 12. We then have the 6 over 12, which is 1/2. Then we have the 7 over 12, which was originally out of 12, so that's fine. And then we have our final one there, 9 out of 12, which is our 3/4. And there we go, using a common denominator, we've got them all in size order and put the original fractions back. On to question 12, we have a transformation. Now there's 4 different transformations you can have. You can have to do a reflection, a rotation, an enlargement, and what we have here, which is called a translation. So a translation is when you are moving a shape and doing nothing else to it, you're just moving it in a particular direction. So it says, describe fully the single transformation that maps triangle C onto triangle D, and you do need to read these carefully, just in case it says from D to C. It's quite natural for us to look at left to right, but just check the language carefully. This one is from C to D. So how do we get there? Well, the first thing we need to do is we need to say it's a translation, which means to move. So a translation, which is just a fancy mathsy word for move. We then need to pick the same vertice on one of the shapes. So let's go with this one, and on the other shape, it'll be this one. So it's in the same position on the shape. I'm then just going to count some jumps how to get there. You can either go right and up or up and right. It doesn't matter either way. We just need to count that distance. So it's 2 up. You can write 2 if you want, so you don't have to go back and count it again. And then 1, 2, 3, 4 to the right. Now when we describe a translation, we do it using a vector. And a vector we have like this. The top number is left and right. The bottom number is up and down. So for this one here, we're going to do the left and right first, the number on the top. So we'll say translation by the vector, and then we'll write what that vector actually is. So it's gone right by 4, which is a positive 4, and up by 2, so positive 2 on the bottom. So there we go, there's my translation by the vector for 2. Not forgetting, if it went left at all or down at all, you would use negative numbers, and there's a massive hint for you there on the axes. The positive numbers are to the right and up, the negative numbers are to the left and down, looking at our axes there. So there we go, that was a translation. You could also have to do a rotation or a reflection, but we had a translation on this one. On to this one. A bag contains red counters and blue counters only. The number of red to the number of blue is 3 to 4. Write down the fraction of the counters that are red. Well, first of all, let's just label this ratio so it's red on the left, blue on the right. So the fraction that are red, well, that's going to be the 3. So definitely 3 out of, and in total, 3 plus 4 gives us 7 parts. So it's 3 out of 7. Really nice turning a ratio into a fraction. Just make sure you add them together to get that denominator. For part B, we've got write the fraction 12 to 30 in the form 1 to n. Now, I really like this sort of topic when we're just doing it to the form 1 to n, because I don't even have to think about how to simplify it. I know if the left number here is turning into a 1, then I have to divide by whatever number's currently in that position, and we've got a 12 there. So I need to divide by 12. At this point, we might not like that because 30 doesn't divide perfectly by 12, but that is even better because it means I don't even have to think about the division. I can just write 30 over 12 as a fraction, and I can leave it like that. It doesn't say there that n has to be written in a particular way, so 1 to 30 over 12. Now, of course, hopefully you are already in good habits of simplifying fractions, so you could look and simplify this fraction. They do both divide by 6 or 2. There's different numbers that you could divide by here, but if we simplify it by dividing by 6, that would give us 5 over 2. And 5 over 2, you might know, is 2.5. It fits in twice, remainder 1, so 2.5 or 2.5. Now, you can write it as 2.5 as well. It's absolutely fine. You can use any of these numbers. I'm going to write it as 1 to 2.5, just because I've gone through the process of simplifying it now. I may as well write it in that form. But 30 over 12 there would have been absolutely fine. So there we go, 1 to 2.5. Next question, we have some substitution. So it says P is equal to 7Rs plus 3Qs. Find the value of P when R is 5 and Q is negative 4. So nice question. The only thing that we are going to need to watch out for is that negative 4 and just start dealing with positive and negative numbers. So we have 7Rs, which just means 7 times R, and R is 5. So 7 times 5 is 35. We then have 3 lots of negative 4, 3 lots of Q. So we need to be careful. 3 times negative 4 is going to be, well, 3 times 4 is 12, but it's negative 4, so it's negative 12. And then I just need to put these pieces back in place, not forgetting that there is a plus symbol in the middle there. So I have 35 plus negative 12. When you have a plus and a minus symbol next to each other like that, that does just turn into a subtraction. So it is just 35, take away 12, which is 23. And there we go, that'll be our final answer. The only one you really have to be careful of in terms of the symbols is when you have that double negative, so something like 35 take away negative 12. Now in that scenario they turn into a plus. It's one of the only scenarios where they do, but there you go, that's the ones to be really careful of. Had it have said 7R minus 3Q, then you might have had that scenario, or you would have had that scenario involved, so you'd have to be really careful. But there we go, let's get rid of that because it wasn't a takeaway. Okay, on to question 15. Right, now this one is asking us to draw a pie chart. Now I have put a protractor into this just so we can draw this pie chart a little nicer. You might only have a 180 degree protractor, but at least we can draw an accurate one on the video, which will just help us out a little bit. So a group of football fans were asked what their half-time snack was. The table below gives the information. Draw an accurate pie chart. I'm always really happy when I see a pie chart because I know, particularly on these exam questions, that these numbers, whatever they add up to, have to be able to turn into 360. Not necessarily always the case in real life, but in these questions it needs to, otherwise we're going to really struggle to actually draw this. So if we add them together, 11 plus 17 is 28, plus the 8 is 36, and that's like the best number that we could possibly get. because if we want to make this add up to 360 degrees, which is of course the angles within a full circle, we just need to think what we multiply by, and 36 to 360 is like the nicest one ever. We're just timesing by 10. So if we times all of these by 10, and remember that number can change depending on what the total is, we get 110, 170 and 80, and we just need to draw those angles on the pie chart. But showing that bit of working out there is really important. Now remember, they could have added up to a different number. They could have added up to, say, 180. If they added up to 180, you times them all by 2. So whatever it takes to get them to 360, that's what we have to multiply by. So for the first one, we have 110 degrees. So I'm going to go from the centre, I'm going to measure this out using my protractor. If you have a 180 degree protractor and you're measuring clockwise, you need to use the outside numbers. There we go, that's 110 degrees. And we'll label that with whatever it is, so that relates to the burger. There we go. Our next one is 170 degrees. Now, if you have a 180 degree protractor, it is a bit easier, to be fair, because you can now rotate your protractor around and make sure 0 is pointing down that new line. As I'm using a 360 degree one, I'm going to have to add 170 onto my 110, which is going to be 280. So I need to go all the way over by 280. So there we go, there's 280, join that up to the centre, and there we go, that's that one there. And that is for the pie. There we go. And for the last one, we have a hot dog, and that's meant to be 80 degrees. It does go from 280 there up to 360, so I'm happy with that. My final piece is correct, so that is the hot dog. And you can write all the angles in if you want as well. So I could write 110 degrees, 170 degrees, and 80 degrees, but definitely label those parts of the pie chart with the words. If you want to add the angles in as well, that's absolutely fine. Just make it look a bit neater. But there we go. There is our pie chart, making sure they add up to 360. Question 16, we have a speed or distance time graph here. Caitlin cycles to her friend's house. She stays at her friend's house for a number of minutes. Then she cycles home, and here's the travel graph of her journey. So you can see that she starts cycling to her friend's house at 8 o'clock. She goes to here, which is 8:20, and then it looks like she actually gets a little bit faster because it changes direction. So she gets a little bit faster. She then stops at her friend's house for a number of minutes, and then she starts cycling back home again, and she gets home at 9 o'clock. So this whole thing was wrapped up within 1 hour. So it's going to ask us some questions about this, but that's what the graph shows us. So it says, for how many minutes did Caitlin stay at her friend's house? So ideally, you want to get a nice long ruler here. You want to have a look carefully so you can join this up to the bottom and see exactly what times these land on. So that is 8:30 and that is 8:45 in the middle there. So from 8:30 to 8:45, well, that's 15 minutes. So 15 minutes she stayed at her friend's house. You can get rid of those lines as well. You just need to put your sort of ruler on there and measure it out carefully. How far is Caitlin from her home at 8:50? And we want that answer in kilometres. So at 8:50, let's have a look where we are at 8:50. Well, 8:50 is all the way over here. And if I go up to my distance time graph, that's 8:50, and it is sort of in the middle, which is a bit awkward. So you're going to be really careful bringing your ruler across nice and straight onto the axes. And there we go. We're going to need to read this number here really carefully. So when you're looking at the axes, do look very carefully because there are 5 squares in between 4 and 5. So 1, the gap between them, divided by 5 would give us, and it's not the nicest without a calculator, so typically it is things like 0.1 or 0.2, sometimes 0.25 if there were 4 squares, but with 5 squares it goes up in 0.2s. So it goes 4, 4.2, 4.4, 4.6. If I mark that out and I keep going up in 0.2s, I'll know if I'm right, because then it goes 4.85. So always just double check the axes there, but that is 4.6 kilometres. So we are on 4.6, and that's at 8:50. Okay, on to the next bit. It says here, work out Caitlin's speed in kilometres per hour for the first 20 minutes of her journey. Well, let's have a look. So for the first 20 minutes, that gets us from 8 o'clock to 8:20. So if I go up and let's just see where we are at 20 minutes. So in 20 minutes, she is 4 kilometres away from her home. So that is the distance she's gone in 20 minutes. So let's write that down just here. So we've gone 4 kilometres in 20 minutes. Now, typically when this comes up on a non-calculator paper, we don't need to use a formula. So you'll know that speed is equal to distance over time, but there's a much easier way to do this without a calculator, and they typically make the numbers really nice for you. That's because 20 minutes can turn into an hour, which we know is 60 minutes in an hour. We just want to know how far she goes in that 60 minutes. Well, to get from 20 to 60, that's just times in by 3. So if she continues at the same speed that she was going at that point, we would just times this distance by 3, and we would get 12 kilometers in 60 minutes. If I go 12 kilometers in 1 hour, that is a speed of 12 kilometers per hour. So always look for those nice little tricks there, because if you're going to do distance divided by time, it's going to be quite awkward, particularly if the speed is wanted in hours and our time is given to us in minutes. It's not going to be the nicest. So do have a look for these little tricks here of how to turn that into 60 minutes. And there we go. That was our speed from the distance time graph. Question 17, we have some angles within parallel lines. So it says here A, B, C and D, E, F are parallel straight lines. ABE is an isosceles triangle. Don't know why they've told us that, because we can see it's an isosceles triangle because we've got these two lines on here, but there we go. They like to tell you everything that's on the diagram. Just be aware of the bits that they're telling you on the wording. Can you already see that in the diagram? If you can already see it, you can pretty much sort of disregard some of the words. Do read them in case they've given you something extra. But it says AB is equal to BE. Okay, well, we know that because we've got those lines that indicate those as the same length. We can see that there's parallel lines because you've got the little arrows there as well. We do need to know that these are straight lines, so that is helpful because unless they tell us that, we don't know if that from B to C up here, for example, is going off in a different direction. So we do because of that language. It says work out the size of angle X and give a reason for each stage of your working. So, when we are looking at these types of questions, there's lots of different routes that you can go on, but one of the first things that I ever look for is, can I see any angles on straight lines? Remember, angles on a straight line only apply when you have a straight line and there's another line coming off it, and it's these two angles that are next to each other that add up to 180 degrees. So we do have one of those. We have that just over here. If we highlight that next to this 142, we have angles on a straight line, so next to that 142, and you want to show you're working out for this, even if you just know the answer. So just write down 180 minus 142, what's that? That's going to be 38 degrees, so that's 38 just there. Now that is the top angle in this isosceles triangle. Now it doesn't matter what direction or orientation the isosceles triangle is drawn in, these little things here, which if we kind of imagine this isosceles is a silly way of remembering it, but if we imagine that this isosceles triangle kind of had like little eyes, and I'm no artist, then those are kind of like his eyebrows. Okay, so the same angles are just below those little eyebrows, which means these are the base angles. So even if I draw this triangle sort of upside down or at a weird angle, well, underneath the eyebrows are now up here, but the triangle itself can be rotated round. So in this question, the two angles that are the same are here, just underneath those eyebrows there. They are equal angles in an isosceles. So we want to find out what they are. So if the top angle in an isosceles is 38, let's get rid of this one. We want to take that away from 180, which we actually already did over here. So we know that's 142, but we'll write it down anyway. 180 minus 38 is 142. If both of the angles are equal, then we want to do 142 divided by 2. If you're not sure what that is, you can do bus stop, but 140 divided by 2 is 70, and 2 divided by 2 is 1. So they are both 71 degrees. Let's label that on the diagram. Now at this point, I've done quite a bit of working out, and I don't want to forget to give my reasons. So I am going to start writing the reasons down now. So my first reason, which I did sort of talk about, but we would write next to this, and you can label it on the diagram or you can write it down below. Just say angles on a straight line equal 180 degrees. So there we go, I can speak a lot faster than I can write. Angles on a straight line equal or add up to 180 degrees. The next reason that we've used angles in an isosceles triangle, or base angles in an isosceles are equal. We know angles in a triangle equal 180 degrees. We could write that one down as well, but the main one I want to write here is that base angles in an isosceles are equal. And it can feel a bit strange saying base angles when they're not necessarily on the base because it's been tilted on its side, but that's just what they're called, the two base angles. Now again, you can label that next to the angle as well. So there we go, I'll just point it at the angle. Now I'm almost there. I've got two ways that I can find the final answer. I've got the way that I can just do it in one step now, which is using my parallel lines. Or I've got to use parallel lines in either of them, but there are two ways that I could go about it. I'm going to go for the easiest route here, and it's using an alternate angle, which makes this sort of Z shape here. So the final angle is using alternate angles to find this one. So for that one there, alternate angles are equal. So that 71 is the same as this 71 here. And next to that, I just want to write alternate angles are equal. There we go, alternate angles are equal. And that reason there is really important because we are dealing with parallel lines. So you're going to be using one of the parallel line rules in any question that you look at. So if you can't use alternate angles, you might have corresponding angles, which are angles on the same side, or you might have co-interior angles. So co-interior angles are like these two here, so this 142 and that one just down there, they add up to 180, so this is also equal to 38. And then you could do angles on a straight line and things like that, but there's always multiple different ways of getting to the answer when we have parallel lines involved. So you've got to be really confident with those different angle rules. But there we go, our final answer was 71. We've given all of our reasons, lots of marks for those types of questions, and there we go, 71. This next question says that Jay drives from London to Swindon at an average speed of 54 miles an hour. He drives for an hour and a half, work out the distance from London to Swindon. Now this is also one of those really nice questions where we're dealing with speed, because they are relatively nice. They give you things like an hour and a half, or it might be 2.5 hours. But that proportion of the distance is really important. It says here he drives 54 miles per hour. So in the 1 hour, bearing in mind he does an hour and a half in total, but in the 1 hour he does 54 miles. Because he does 54 miles per hour. The half an hour, which is half of that, he would do half of 54. Dividing that by 2, you get 27 miles. So overall, in the hour and a half that he's going 54 miles per hour, he does 54 plus 27. So we just need to add those two together, 54 and 27. Add those up, 7 plus 4 is 11, 5 plus 2 is 7, plus the 1 is 8. So he does 81 miles in total. So don't try and overcomplicate some of these questions. They're not trying to catch you out with these times, hour and a half or 2.5 hours. Remember, you're looking at that proportion. If they gave you a quarter of an hour, that'd be quite a horrible one, but you just have to half the half an hour. And that one you'd have got a decimal, so they'd probably give you a number that wasn't so nasty to do a quarter of an hour. But there we go, if you had to do a quarter, you could halve it again, get your quarter of an hour, and sort of figure it out from there. Next part, a mayor is using a map. The map has a scale of 1 to 25,000. On the map, a road has a length of 6 centimetres. Work out the length in kilometres of the real road. This actually isn't very nice. Now these sort of scale questions I actually really like. I think they're quite nice questions because 1 to 25,000, it just means that it's 25,000 times bigger. Not the nicest of numbers in terms of 25,000, but if it's 6 centimetres on the map, that is timesing by 6. So all we need to do is do 6 times 25,000, or 25,000 times 6, whichever way you look at it, and we'll have our distance there. But that, of course, is going to be in centimetres, and the reason I think this one's quite a tricky one is because it then wants it in kilometres, so we're going to have to convert it from centimetres. So 25,000 multiplied by 6, let's just do 25 times 6, because 25,000 times 6 seems awful. 6 times 5 is 30, 6 times 2 is 12, plus the 3 is 15. So we had 3 zeros obviously at the end here, so that's 150,000 with those 3 zeros, and there we go, so that's 150,000 centimetres. Now it wants the distance in kilometres, so 150,000 centimetres, while there are 100 centimetres in 1 metre. So let's first turn it into meters. I'm not going to try and jump from centimeters straight to kilometers. So we'll divide by 100, which turns it into meters. That's just going to cancel off 2 of these zeros. So that is 1,500 meters. There are 1,000 meters in 1 kilometer. Remember, kilo means 1,000 there, so it's 1,000. It literally means 1,000 meters. So dividing by 1,000. So 1, 2, 3 hops of the decimal in there. 1, 2, 3. That's going to be 1.5 kilometers. And there we go. There's our final answer, 1.5. So there we go. You do need to know those conversions. 100 centimeters in a meter and 1,000 meters in a kilometer. Really important ones to know. Okay, on to our next question. Okay, so straight away I see a shape and it's got algebra on. Very, very unlikely it's going to be anything other than forming and solving equations. So this is where we need to know our equations. Now, part A is really interesting here. It says A to B is 4x minus 2, which is the length of that part of the kite up there. Don't forget, on a kite, these two lengths are equal. And also, and I'll do 2 lines for this, these 2 lengths are equal as well. So that's the mathematical knowledge you need to know about a kite here. It says Jaya says that x could be 0.5. Explain why Jaya cannot be correct. Now, don't forget in these questions, when it says they cannot be correct, they are never correct. So you're always trying to prove why they're not. So don't say Jaya is correct. Okay, she's wrong. It tells us she's wrong. So if x is 0.5, well, if the side length is 4x minus 2, which of course means 4 times x, take away 2, well, let's just put it in and see what we get. So that's 4 times 0.5 and take away 2. 4 times 0.5. Now that's not an awful one to do. So 0. If we count in 1/2, 1/2, 1, 1.5, 2. So 4 lots of 0.5 is 2. So that's 2, take away 2, which gives us 0. Well, that's absolutely impossible. You can't have a length of 0. You can't have a kite where one of the sides is 0 centimetres. So Jaya cannot be correct. You cannot have a side length of 0. There we go. Have a side length of 0. It's not possible. It doesn't exist if the side length is 0. So there we go. There's that one. Some substitution. You can always put your value of x back in. That's, of course, an incorrect value of x, but you could be asked to substitute your own value in. So the next part, it says A to D is 3 lots of A to B. Let's just, before we carry on reading, let's just have a look. So A to D, which is this length here, is 3 lots of A to B, which is this length here. Well, before we even move on, we can actually write what that side length is then, because if it's 3 times the size, we need to times that one by 3. So the 4x would become 12x. The 2 would become 6, and it's a minus in between, so we'll stick that one in as well. So there we go, that's 3 times the length now. Now, as it's a kite, we can replicate these all over the shape as well. So this is 4x minus 2 over here, and that's 12x minus 6 over there. So there we go, that's all the side lengths in terms of algebra. It then says the kite has a perimeter of 64. Find the value of x. Well, if it's got a perimeter of 64, the perimeter is the distance around the outside. So that means if we add all of those pieces together, they equal 64, which is where our equation comes into play. So let's start adding these up. We have the 4x, another 4x, that's 8 in total, plus the 12 is 20x, plus the 12 is 32x. Let's write that down so we don't forget. So 32x. And I'm going to add up all these numbers. Now, purely because they're all negative, what I'm going to do is just add up the actual number themselves and then just stick the negative with it. You've got to be really careful if there's positives and negatives, but they're all negative. So I just need to add them up. So I've got a 6. Let's highlight them so you can see which ones I'm adding. We've got 6, plus 6 is 12, plus 2 is 14, plus 2 is 16, so it's minus 16. Again, you've got to be really careful there if there's positives and negatives, because you'll be going up and down in terms of your counting. So 32x minus 16 is the perimeter. Let's write that down here. 32x minus 16. Let's just double check that was correct. So 12, 24 plus the 8, yep, 32x, and then 6, 12, 30.50, 16, yep, so we're happy with that. 32x minus 16. It says the perimeter is 64. So this expression that we have written, that's called an expression, we are going to turn into an equation. That's how we find the value of x. You'd normally see that sort of language when you're solving. So let's create an equation. Well, it equals 64. And now I need to solve this equation. To do that, we do the inverse. So we add 16 to both sides. Pretty much always going to get rid of that number first by doing the opposite. So 32x will be equal to 64 add 16 is 80. And then we've got to divide by 32, and that's not very nice at all. However, when we divide by 32 here, as we have done earlier in this paper, we can just write that as a fraction. X is equal to 80 over 32. Now, nothing in this question says that that value of x has to be written as a decimal. It doesn't say write it in any particular form, it just says find the value of x. Well, x is equal to 80 over 32. So that's absolutely fine to leave your answer like that. Be absolutely perfectly happy writing that on the dotted line. However, obviously, if you're having a go at this, you may have written it slightly differently. So let's just have a look and see if we can simplify it. So 80 over 32, they both divide by 2, they both divide by 4, they actually both divide by 8. So if we divide them both by 8, you get 10 on the top and you get 4 on the bottom. So there we go, they actually both divided by 16. So let's divide them by 2 because they're still even, both of them. So that would be 5 over 2. And here we go, we've got that 2.5 again that's actually appeared here. So there we go, 5 over 2 is equal to 2.5 or 2.5. There's so many different ways you could write your answer here. I'm going to go with 2.5 as we've just gone through the effort of doing that. So x is equal to 2.5. And I think people are normally more confident or comfortable writing it as a decimal like that anyway. But if you're not sure, you're sort of lost in the moment, it would be fine to leave it as that fraction. Okay, next question is writing an nth term of a sequence. So we're going to look what times table it's related to. Just check, just be really careful if it's going down, but we'll talk about that as well. So here it's going up by 6 and then up by 6 again. So there we go. We did know it was going to be constant. It does tell us it's an arithmetic sequence, which does mean it's being, or there's something being added or subtracted that's the same each time. Write down an expression in terms of n for the nth term. So in terms of n represents the position, but when we have the 6 times table, we just put that with n. So 6n means the 6 times table. However, this is not the 6 times table, and there's lots of different ways of looking at how to get the number that has to go with this 6n. But thinking logically, the 6 times table starts with 6. Our times table here, our sequence here, starts with 5. So it's not the 6 times table as it's one smaller. So to write one smaller, we just write minus 1. So it's the 6 times table minus 1. Now that can be slightly harder when you have a negative sequence that's going down, because sometimes the jump can be quite big from that negative number up to 5 in this case. So if it was sort of going down, let's imagine if it was 5 and then, I don't know, let's just go for a nice one. It goes to 2 and then it goes to minus 1, minus 4. Just going down in 3s. Now that one there, we would write minus 3n as it's going down in 3s, but the negative 3 times table is not something we ever use, so it seems a bit strange writing negative 3 there. But this is a lot bigger than the negative 3 times table because the sequence I've written starts with 5, so therefore it is 8 bigger, so it's minus 3n plus 8. So it's a different type of sequence there, not the answer to this one, but just a different thought process if you have a sequence which is going down. Okay, next one we have some multiplying decimals. When we multiply decimals, let's just get that decimal out. So 1, 2, that'd be 634, and 1 out of the 5.2 gives us 52. So let's times together these now whole numbers. 2 times 4 is 8, 2 times 3 is 6, 2 times 6 is 12. Placeholder, as we're now timesing by 5, which is 50, but placeholder in there, we can use 5 instead. So 5 times 4 is 20, carry the 2 there. 5 times 3 is 15, add the 2 is 17. And 5 times 6 is 30, plus the 1 is 31. Right, we need to add all of these together. Again, when you're doing multiplication like this, just take your time. Make sure you don't scribble in your numbers that you're carrying and write them incorrectly. Just write it all nice and clear. So 8 plus 0, 8, 6 plus 0, 6, 2 plus 7 is 9, 1 plus 1 is 2, and then 3 at the end. Now originally we took 3 decimals out of our numbers, so we need to go 3 back in. So from the end, 1, 2, 3, And there we go, that gives us 32.968. Now you can kind of guess or figure out where the decimal's going to go, because if instead of work out, if it had have said estimate, we can use an estimation process to figure out where it goes anyway. So if it said estimate 6.34 times 5.2, well, in that scenario we'd round them to 6 and 5. 6 times 5 is 30. So you can see here 32, we know it's in the right place. It's not going to be 329 or 3.29, etc. We know it's going to be around the 30. So you can use that process there just to make sure you're very happy with where you've put your decimal. Okay, on to the next one. We have some plans and elevations. It says here the front elevation and the plan of a solid are shown on the grid. On the grid, draw the side elevation of the solid from the direction of the arrow. And then we've got no more information. Typically these are centimetre grids, but we have the front and we have the plan. We want the side, which is from the direction the arrow's pointing. It's a bit annoying that that arrow's there, because I'd like to draw the side elevation right next to it. Now the reason I want to draw it right next to it, and I'm going to redraw it as well, but if I draw it right next to it, I want it to be the same height as this shape here. So I know when I draw that in, I want the height to be that high, so it's exactly the same height. So I do quite like drawing it. This means nothing says you can't draw it next to it. I think they've left us a gap down here to draw it down there, but there's nothing to say you can't draw it right next to the shape. So there we go, there's my height. In terms of the width of this base here, I need to look at the plan. So if you imagine the arrow sort of pointing this way as well, the bottom, or what I'd see there, is 3 squares wide. So this bit here, and that's going to be 3 squares wide. Now it's going to be this sort of rectangular shape, so I can now draw in my rectangle. And the only thing that I need to be aware of now is I would normally add an additional line that just shows where there's a change of depth. Now it's slanted most of the way, but there's this point here that we would see as a sort of change of depth that would create this additional edge on our shape. So all I need to do is take that into account, which is why I like drawing them next to one another. And there we go, I'd have an additional line going across there that just shows where that sort of change of depth occurs. And there you go, you can draw that or redraw it somewhere else if you want, but as I said, I like drawing it right next to the shape so that I can see the heights are the same. And there we go, there's our plan and elevation. Onto some fractions. We have adding some mixed numbers and we have dividing some mixed numbers. One of them wants us to write as a mixed number in its simplest form. The other one just says work out. I like it when it says just work out because I know I don't have to worry about simplification or anything. So to add fractions or mixed numbers, we need them to be improper. So 2 times 7 is 14 plus the 1 is 15 over 7. 1 times 4 is 4, add the 1 is 5 over 4. So there's my first step. I now just need a common denominator. So to get a common denominator, look at 7 and 4 and think what the lowest common multiple is. That's going to be 28. To do that, we times the left one by 4, top and bottom. For the right fraction, of course, we want the same denominator, so 28 as well, and that's multiplying by 7. So you can just multiply by the opposite denominator. It'll always get you a common denominator. So 15 times 4 on the numerator there, well 15 times 2 is 30, so times 4 is double that, 60. And 5 times 7 is 35. From there I can add them together, that comes out as 95 over 28. Now I'm just going to write the answer as 95 over 28 because this question has not specified to write it as a mixed number. It's not specified to try and simplify it, so I'm not going to do so because it's not going to gain me any additional marks. If it did say to do so, of course I would. I'd now start looking at how many times 28 goes into 95. I'd write down some of the 28 times table because I have no idea what that is off the top of my head, and then I'd try and find the gap, you know, from wherever I get to up to 95 to see what's left over. But there we go, 95 over 28. Part B, we want to do a division. To say give it this time, we do have to give it as a mixed number in its simplest form. So I'm going to convert them again. So 1 times 5 is 5, plus the 1 is 6. So 6 over 5 divided by, well, don't have to convert the next one, so 3 over 4. When dividing fractions, we multiply the first fraction by the reciprocal of the second fraction, which you might know as keep, flip, change, or any other method, but 6 over 5 multiplied by, flip the second one over, which is called doing the reciprocal, just where you flip something over, and that is 4 over 3. Multiplication is really nice. You just times the top, so 6 times 4 is 24 and 5 times 3 is 15. And there we go, we have our answer as an improper fraction. Now once it has a mixed number, so how many times does 15 fit into 24? Well, it fits in once, and our remainder from 15 to 24 is 9. So we have 9 left over 15. Now it wants it in its simplest form, so I need to have a look at this fraction. The fraction does simplify. In this case it's 9 and 15. They both divide by 3. So I need to divide them both by 3. The 1 doesn't change, we're just changing that fraction that's accompanying it. So we have 1 and 9 turns into 3, 15 turns into 5. Now that's now written as a mixed number in its simplest form. So there we go, that's if you have to do a division. Of course, if you have a multiplication, it's just times the top times the bottom. And don't forget, if you do have fractions earlier in an exam paper, you don't need to obviously do the conversions, but adding and subtracting, you need to do the common denominator. Multiplication, really nice, just times the top times the bottom. And division, just don't forget to do the reciprocal of the second fraction. On to question 24. Christian puts tins into, I can already see by looking at this question, there's so many words and it's about small and large boxes. It's a huge chunk of text. So I'm just going to just read this and think which line I need to focus in on. So Christian puts tins into small boxes and into large boxes. That's just giving us some context. I don't need to read that again. He puts 6 tins into each small box and he puts 20 tins into each large box. Okay, so 6 tins in a small box, 20 tins in a large box. Christian puts a total of 3,000 tins into the boxes so that the number of tins in small boxes to the number of tins in large boxes is 2 to 3. Christian says that less than 30% of the boxes filled with tins are large boxes. Is Christian correct? You must show your working. So that second line, or those last 2 lines, is asking us some information about what we need to work out. So we need to work this out and then we'll think about the 30%. At the moment, there's too much information there to even try and think about that. So let's look at what we've been told. Christian puts a total of 3,000 tins into boxes, and then small to large is 2 to 3. Now let's get rid of those 2 lines by writing that as a ratio to the side. So we have small and large, 2 to 3. Now, there are 3,000 tins in total, so that's what we need to split in the ratio 2 to 3. Now, in total, there are 5 parts. So I need to divide that by 5. Let's do it to the side. 3,000 divided by 5. 5 goes into 30, 6 times, and then 0, 0. So each part is worth 600. So I need to multiply both numbers in the ratio by 600. 2 becomes 1,200, 2 times 6, add the zeros, and then 3 times 600, 3 times 6 is 18, add the 2 zeros. So there we go. We know out of the 3,000 tins that Christian has, there are 1,200 tins to go into small boxes, and there are 1,800 tins to go into large boxes. Now it says Christian says that less than 30% of the boxes filled with tins are large boxes, but we don't know how many boxes are filled, we just know how many tins are in them. So the next step is to work out how many boxes we actually have. So it says he puts 6 tins into each small box. Now there are 1,200 tins in small boxes. So how many boxes will that be? Well, if there's 6 tins in each small box, that would be dividing it by 6. So for the small boxes, and I could just write this over by that ratio, but I'm going to label it really clearly. I need to do 6 into 1,200. So 6 into 12 goes twice. 2 zeros. There are 200 small boxes, and for the large boxes we have 20 tins in each box going into 1,800. Now, not the nicest there when you are dividing and you have a number, like a double digit number like this with a 0 at the end. We can get rid of a 0 from both. You don't have to add them back on or anything like that. It's much easier now to do 2 into 180. 2 goes into 18, 9 times, and then 0. So there are 90 large boxes. So there are 200 small boxes, 90 large boxes. Christian says that less than 30% of the boxes filled with tins are in large boxes. Well, we know that there are 90 large boxes. So we just need to know, is that less than 30% of the boxes? Well, how many boxes are there in total? There are 200 small plus the 90 large. That's 290 boxes in total. There we go. So Christian says less than 30% of the boxes are large boxes. Is he correct? Well, if we work out 30% of this number, so 30% of the boxes filled, let's work that out. Without a calculator, we do 10%. So 10% is 29 boxes. 30%, we would just need to multiply that by 3. We'll take our time, we'll do it to the side. So 29 times 3. 3 times 9 is 27. 3 times 2 is 6, plus the 2 is 8, so 87. So 30% of the boxes would be 87. But we have 90 large boxes. So 30% of the boxes is 87. We have 90 that are actually filled. So Christian says less than 30% are filled with large boxes. But we have 90, which is more than 30%. So no. So we would just have a statement. Just say, is Christian correct? You must show all your working. So no, Christian is not correct. There you go. You can write as much information as you want. You could write because he has 90 large boxes and 30% is 87. But I've backed that up. I've shown my working really clearly, so I don't feel like I need to add any additional information. And there we go. That was that question. That is a very tricky question, actually, because it wasn't just sharing in a ratio. It was then actually manipulating the ratio into boxes instead of tins. So that's quite a tricky one. Might be one that you want to watch again. But there we go. There is a tricky ratio question. Okay, on to our next one. We have what looks like a sampling question. So work out how much ham pizza Miley should order. Yep, so we're looking at a sample. There are 1,200 students in a school. Miley is helping to organise a party. She's going to order pizza. Miley takes a sample of 60 of the students at the school and she asks each student to tell her one type of pizza that they want. The table shows the information. So it tells us this is a sample of 60. So whichever one we are looking at as a fraction, we can write out of 60. So the ham pizza is 20 out of 60, and each subsequent one is out of 60 as well. So salami is 15 out of 60, vegetarian is 8 out of 60, and margarita is 17 out of 60. So we want to look at the ham pizza. So that's good because that was the first one. It's the first one we've written down. Now when you're looking at these, there are now two ways that I could approach this. So if it's 20 out of 60, well, it said that there are 1,200 students. So I don't want it to be 20 out of 60. I want it to be out of 1,200. Now, without a calculator, you could think to yourself, well, how do we get it out of 1,200 and have a look at the numerator? However, as we're doing this without a calculator, I'd first want to look at the fraction here and think, does it simplify? Well, they both divide by 20. They both divide by 2 or 10, but 20 is the biggest thing that they divide by. So if I divide them both by 20, we get 1 over 3. And all of a sudden, this has become a lot easier because if it's 1/3 of the pizzas that we want to be ham pizza, well, if there's 1,200 students, then I want to find 1/3 of the 1,200 students. Now to do that, we just divide by 3. So 3 into 1,200, 3 goes into 12 4 times, and then 0, 0. So our answer would be 400 for that one. Now, for the next part, or the previous method, we could have thought about that as well. So to get from 6 to 12 is 2, and there's another 0 there, so that's actually times in by 20. So 2 times 60 is 120 plus a 0. So if we times the top by 20 as well, you do get 400 here, so our answer would be 400 as well. Okay, so the next one says write down any assumptions you made and how this could affect your answer. Now, we pretty much always give the sort of same answer for this one. We assume that the sample represents the rest of the students. Okay, so we assume that the sample represents, that word represents is a really good one for this, represents the rest of the students. Okay, now obviously what we mean by that is that we assume that for every 60 students, 20 of them are going to want ham pizza. It'd be a very extreme scenario, but if they just happen to be the only 20 that were asked, well, we're going to be ordering way too many ham pizza. If they're the only 20 in the entire school that actually wanted ham pizza, there's going to be a lot of people with pizza they don't want. It's very extreme there. So what we are assuming that the sample represents everybody. If not, because it said explain how this could affect your answer, so we would say if not, okay, our answer, specifically referring to our answer here, as that's what it's asked about, our answer could be bigger or smaller. Okay, could be either way, or smaller. There we go, and that would be our final answer, bigger or smaller. And there we go. So we assume the sample represents the rest of the students. If not, our answer could be bigger or smaller. Okay, on to our next one. We are looking at pressure, force, and area. It's a relatively nice one here, but it says a storage tank exerts a force of 10,000 newtons. So we've got quite a relatively large number to use on a non-calculator paper, but the force is on the top just here. So it's told us the force, that's 10,000. It wants us to work out the pressure, so we need to know the area. If we want to work out the pressure, we need to know that area. It says the base of the tank in contact with the ground is a 4 metre by 2 metre rectangle. So this length along the bottom here is 4 metres, and this one is 2 metres. To work out the area of a rectangle, we just multiply the length by the width. So the first thing I want to do, 4 times 2 is equal to 8. That'd be 8 metres squared. That's the area of the base. So that means in our fraction here, which is given to us, we have the number 8. So to work out the pressure, I need to do 10,000 divided by 8. Now, of course, I want to take my time with that, so I'm going to use bus stop division again. So 10,000 divided by 8. 8 goes into 10 once, remainder 2. It goes into 20, twice, remainder 4. It goes into 40, 5 times, and then 0 at the end. So there we go, we have 1,250. Now that's newtons per metre squared. It does normally give you that on the dotted line there, but it's newtons per metre squared. We know what it is anyway, because that was 10,000 newtons on the top, metres squared on the bottom. You are dividing them, so you get newtons per metre squared if you think about that slash as a divide. So newtons per metre squared. So 1,250 is our final answer. Okay. There are only blue pens, green pens, and red pens in a box. The ratio blue to green is 2 to 5, and the ratio green to red is 4 to 1. There are less than 100 pens in the box. What is the greatest possible number of red pens? Now, before we look at this next part there, I've already noticed there is a crossover thing, in this case, green pens, in both of these ratios. Now, whenever we have that, it's always good practice just to make that number the same and just write it as a 3-part ratio. So in the first one, the green is a 5. In the second one, the green is a 4. So if I multiply these to make them the same number, let's think the lowest common multiple of 4 and 5 is 20. So I would want to multiply the top ratio here by 4, which would give me 8 and 20. And the bottom ratio I want to multiply by 5. So that would give me 20 and 5. Just remembering what if I multiply one part of the ratio, I multiply it all by the same thing. So multiplying the top one by 4, the bottom one by 5. Now that number for green is now the same in both. So if I write this as a 3-part ratio, blue to green, I'm just sort of reading the language here, going through it in order, blue to green to red. Blue we have now got as 8, green is 20 in both, so we can write 20, and red is 5. So we now have this as a 3-part ratio, and that can be applied to any question where there's a crossover thing in the ratio. And typically when you're given 2 ratios, it's normally because it wants you to join them up. It says that there are 100 pens in the box. What's the greatest possible number of red pens in the box? Now, it might be that we're already at the limit. So let's just have a look. If we add these all together, like we normally do with ratios, 20 plus 8 is 28, plus the 5 is 33. So I need to think about what number I can times these all by, so it gets pretty close to 100. Now, if I times them all by 10, for example, I'd have 80, I'd have 200, I'd go way over that 100 mark. So I need to think smaller. I need to think about 33. What could I times that by to get close to 100? Well, if I times it by 2, that would be 66, still quite a bit under. If I times it by 3, I get to 99, which is obviously 1 under, so I definitely can't go any higher than that. So if I times it by 3, I get 99. What's the greatest number of red pens in the box? Okay, well, the greatest number we could have of pens in the box is 99, but this wants to know the red pens. It doesn't really matter which one it wants to know. I could just times them all by 3. So I'd get 8, 16, 24. 20 times 3 is 60. 5 times 3 is 15. So there are 24 blue pens, 60 green pens, and 15 red pens. If there are less than 100, the most amount of red pens I could have in this particular ratio would be 15. And there we go, that's the greatest possible number of red pens. On to question 28. We have, in a sale, normal prices are reduced by 20%. The normal price of a coat is reduced by £15. Work out the normal price of the coat. You've got 2 scenarios in these questions. Either when 20% has been knocked off the price, that leaves us with 80% of the value left. Now you could be given either the 80% or the 20% when we have a reverse percentage, where it's asking us to work out the normal price before the sale happened. So going back into the past. So it says here the normal price of a coat is reduced by £15. You can actually see in the language here, the language actually matches. Reduced by 20%, reduced by £15. So that 20% is the £15. So this is quite a nice one. Had it have said the normal price of a coat after the reduction is £15 or something along those lines, the sale price of the coat was £15, well that would be the 80%. So here I just want to write down what percentage we've been given. So 20% is equal to £15. Now this is a particularly nice one, and I say it's a nice one because 20 can turn straight into 100%. To get there you can actually just times by 5. 20 times 5 is 100. However, that's not going to work on every question, and on some questions we may have to go down. If we do have to go down to 10%, you can divide by 2 for this one, and then times by 10. That would be absolutely fine. I'm going to jump straight down. It's actually already doing £15 times 5. Might be easier to go down. Actually, it's definitely not. Oh no, it actually is, because if we go down to 10%, you get £7.50. Half of £15. Depends if you like dividing by 2 or timesing by 5 better. But timesing by 10 is really nice. You just hop that decimal over, you get £75. So it doesn't matter which way you do that, whichever way gets you back to that 100%. You could also times it by 4, which would get you 80%, and then add them together, whichever you prefer, but you've got to get back to that 100% when looking at a reverse percentage. And you have to read the language very carefully. This one, the language matched, reduced by 15%, 20% reduced by £15. But just be careful, it could have said the sale price is £15, which means it would be the 80%. But there we go, there is a reverse percentage. Our final answer, £75. On to the next one. Straight away I can see that it's given us a mean. 4 red bricks have a mean of 5. Now whenever we are given a mean, it's a reverse mean question. So normally when you find the mean, you add them all up, divide by how many there are, you get the mean. Now in this question, it's given us the mean and it's given us how many there are. And the reverse of the normal process where we are doing a division is just that we have to multiply. So you can write this as a sort, and I won't write this for every single one because it's actually much quicker than this. But if we have 4 red bricks that have a mean of 5, it means the total weight of the bricks, which we don't know, let's call it x, divided by the 4 bricks gives us a mean of 5. And you can see there, to get x on its own, you've got to times both sides by 4, and you get x is equal to 20, or the total is 20. Now really all we have to do is match them together in each line. So here we have 4 bricks with a mean of 5, so 4 times 5 is 20. For the next one we have 5 blue bricks with a mean of 9, so using the same process, 5 times 9 is 45. And we have this last one, we have 1 green brick which has a weight of 6. Now I'm still going to write it out, 1 brick times 6 gives us a total of 6. You didn't really need to write that multiplication down there. So that's the total weight of all these different bricks. It says here, Donna says the mean weight of the 10 bricks is less than 7. Is Donna correct? And you must show how you get your answer. Well, it's asking us now to work out the mean, isn't it? We've got 10 bricks, which is really nice, which means I'm going to have to divide by 10. But if we add all of those weights together, so 20 plus 45 is 65, plus 6 is 71 kilograms. So to get the mean, we would do 71 divided by 10, and that comes out as 7.1 kilograms, which is the mean weight of each brick, and there are 10 bricks. So Donna says the mean weight of the 10 bricks is less than 7, but the mean weight was 7.1, which is more than 7. So is Donna correct? I would just say no. Donna is not correct, or Donna is incorrect. And there we go. And there's our final answer. And I've shown how I've got my answer. I've got the total weight of each brick. I've added them all up and divided by 10. And I've written my little conclusion. Okay, next question. We have an error interval. It says a number, m, is rounded to 1 decimal place, and the result is 9.4, complete the error interval. So with an error interval, don't forget, particularly when there's decimals involved, you just need to put a 5 after the number for the bigger, or what you call the upper bound there. So for the big one on the right, I just put a 5 after the number, 9.45, and even if you're really stuck, at least you can get yourself 1 mark on that question. So this is all just about rounding. We have 9.4 in this question, which is in the middle of, to 1 decimal place, 9.3 and 9.5. And all we're doing is looking at these midpoints, the cut-offs, where it rounds to 9.4. We've already got the larger one, 9.45, and if you want, you can add zeros onto these. It just helps you to visually see the middle of 9.40 and 9.50 is 9.45. And in between 9.3 and 9.4 is 9.35. So there we go. Our lower bound is 9.35, and there's our error interval. On to question 31, which is our final question. We have factorising x squared plus 3x minus 4. Now, we wouldn't have any sort of factorising of nicer sort of expressions within this one, but you could have something. It'd definitely be earlier in the paper, but you could have like a 30x sort of, plus 15. And in that scenario, you've got to have a look at what they both divide by. Now, they both divide by 15. So you'd have 15 on the outside, and then 2x plus 1, what you times 15 by to get back to it on the inside. And it makes this nice single bracket. And you can also have expressions like that where there's a squared involved. So you could have 30x squared plus 15x, and that also goes into a single bracket. It's just that you have to take x on the outside as well. Now this has a squared in, but it's a little bit different, because if you look at these, they don't all divide by anything. And when that happens, it's because it's a double bracket. And hopefully you recognise double brackets because you've done expanding double brackets as well. But that is a double bracket that it factorises into. To find the numbers that go in those brackets, we look at the 4. So it's either going to be 1 and 4, numbers that times to make 4, or 2 times 2. Now to figure out which pair of numbers it is, because we're almost done now, it has to be one of these pairs of numbers. I look at this number in the middle, the plus 3. So how can I make plus 3 using 1 and 4 or 2 and 2? Well, with 2 and 2 you definitely can't do it, so it's not 2 and 2. So it has to be 1 and 4, so I can put the numbers in straight away, and even if I get the symbols wrong now, I'm at least going to get 1 mark. Now to get plus 3, I want that to be 4, positive 4, take away 1. If I did it the other way round, positive 1 take away 4 would be negative 3. So I want it to be plus 4, getting as close to positive 3 as I can, and then take away 1. And you can write those in either order. You could write x plus 4 and x minus 1 the other way round. As long as the plus symbol's with the 4 and that negative symbol is with the 1, we're all good. So I can write my answer the other way around if I want. I could write x plus 4 and x minus 1. It doesn't matter which way you write it, but there we go. And there we go. That is factorising a quadratic. And obviously just making sure you recognise the difference between something like that and something like 8x squared minus 4x or something like that, whereby they both divide by 4, so we can definitely do a single bracket. They both have an x in, and then you've got to think what do you times 4x by to get back to it. We'll finish it off, so 4x times 2x would get you the 8x squared, keep the symbol the same, and 4x times 1 gets you to 4x. So that will simplify like that. That's a different question because you are simplifying into a single bracket. But there we go, that is the end of the paper. Obviously, there will be more videos and papers coming out for paper 2, so do watch out for the paper 2 version of this as well, where we'll be having a look at some calculator skills and any topics thinking about paper 2 after we've completed paper 1. So there we go, that is the end of this particular video, but obviously I wish you the best of luck for your exam, and Do leave me any comments in the bottom if there are any topics that you want to revise. I can help link any videos. Do check the description because I will link the full videos to any of these topics in the description. So if there's anything that I went over in this video that you're not so sure of, you can head into there, you can check out the full video, you can practice lots of different questions on it. But there we go, as I said, good luck in the best of your exam. That's the end of the video, and I'll see you for the next one. Now hopefully you've got your revision under control and you're making great progress towards paper 1. But if you're struggling to know where to start and need to maximise your maths in minimum time, then you should sign up for my rapid revision programme, Upgrade, as you can use it to build your very own personalised revision plan. Which means all you need to do is complete my revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but you can sign up for a free trial on my website now. And if you feel like you need top tier support direction from me, then sign up for my live weekly interactive lessons, which include revision specific lessons focusing on the topics that I expect to appear in exam papers 1, 2 and 3.